Factoring is one of the most important things you're going to learn in your algebra class, and the most important type of factoring is that of factoring out a greatest common factor, because you will always be looking to factor by a GCF the very first thing when you're trying to factor any problem. What you're going to do in this first problem is ask what can go into both 24x and 36, and the answer is 12x, or just 12, is the largest thing that will go into each term. And when 12 is divided out of each of these two terms, we are left with 2x minus 3. Now let me call your attention to something. 12 was not the only thing that could be divided into both 24 and 36. For example, 6 goes into each. And if you divide 6 out, you have 4x minus 6. And you may look at this and say, I've factored the 24x minus 36. But notice how inside this parentheses, 4 and 6 are both even, and another 2 can be factored out. When you factor, you are always factoring completely, and you always must take out the greatest common factor, not just any common factor. So after you've taken a GCF out, look at what's inside your parentheses and make sure there's nothing common that can be divided out from either of them. In this next problem, we see that an 18 is common to both terms, but that an x can be divided into each term also. And so the greatest common factor is 18x. Dividing it out of the 18x squared, we have x, and dividing it out of the minus 18x, we have minus 1. Make sure to put that minus 1 in there as a placeholder. And I should have mentioned this up above, but you can always check, and you probably should do this mentally, that you can redistribute to get back to the original problem. In this next problem, 20 and 24 both have a factor of 4, and then we look at each variable, x to the fifth and x to the second. X to the second goes into x to the fifth, so for each variable you're going to choose the smaller exponent. Y to the third versus y to the fifth, we're going to divide out a y to the third, and z to the second versus z, we will divide out a z. And then we will actually do the factoring, do the division. 20 divided by 4 is 5. X to the fifth divided by x to the second is x to the third. Notice we are subtracting exponents. For the y to the thirds, it all divides out, and then z squared divided by z is z left over inside. Negative 24 divided by 4 makes a minus 6. The full x squared divides out, but when you divide y to the fifth by y to the third, you will have y to the second left over, and the z divides out, and so we have what's left in the parentheses there, which can be checked again by distribution. In this next problem, there are 3 terms. We need to ask what goes into 14, 28, and 35, and the answer is 7. And then we look at the variables, x to the fifth, 7th, and 2nd, and we take the smaller of them, x to the 2nd. For the y's, we look at y to the 3rd, y to the 2nd, and y to the 8th, and y to the 2nd is the smallest. Dividing it out of each term, we are going to have 2x to the 3rd y minus 4x to the 5th plus 5y to the 6th. Now I divided each of the coefficients by 7, and I subtracted 2 from each of the exponents in getting to my solution. In number 5 here, we do not see any number or variable that's in common between all the terms, but there is a negative for this leading coefficient. And when that's the case, we like to factor out a negative 1 and change the sign of each term inside the parentheses, because we do not like to have a negative leading term for a polynomial. So we factor that negative 1 out.